Welcome to this explainer. Today, we're unpacking a scenario that honestly sounds like it completely belongs in a summer sci-fi blockbuster, but is actually grounded in some very sobering, hard science. We're going to examine the catastrophic data derived directly from the 2024 Global Catastrophic Risk Assessment. Now, it's a heavy subject, for sure, but understanding the scientific reality of our planet is absolutely crucial. We're looking at what experts call Yellowstone Rising, the harvest of ashes. Together, we're going to look closely at the geological mechanisms, the agricultural fallout, and the massive global climate chain reactions of a supereruption.
95%. I want you to just imagine for a second the American Midwest, the region we universally recognize as the breadbasket of the world. Now imagine it suddenly and completely buried under a thick blanket of what the assessment refers to as gray death, the sudden loss of 95% of U.S. food. That is the stark, undeniable reality presented in this data. Okay, let's dive into this because this isn't some movie script. It's exactly what the data projects happens when a supervolcano like Yellowstone finally wakes up. The sheer scale of this event is kind of difficult to conceptualize, but that is exactly what we're going to do today by breaking down the science step by step.
Section 1. Waking the supervolcano. The geological reality of a Yellowstone eruption.
To really understand the fallout, we have to look at the mechanics of the volcano itself. Like, what exactly makes an eruption a supereruption? Well, the scientific definition is the sudden release of at least 1,000 cubic kilometers of magma. To put that into perspective, that is literally enough material to fill the entire Grand Canyon right to the brim. It's almost unimaginable. And because this immense force is just so incredibly large, it doesn't just push rock up to build a towering mountain. Actually, scratch that, it doesn't build a mountain at all. Instead, the release is so violent that the earth above it essentially collapses, destroying the crust to form a massive, sunken crater called a caldera.
And this brilliantly illustrates the point. To grasp the sheer, terrifying scale of this thing, we can compare a known historical event, the devastating 1980 eruption of Mount St. Helens, side by side with a projected Yellowstone supereruption. The data shows Yellowstone is a staggering 1,000 times larger. Think about that, 1,000 times the magnitude. By contrasting the known destruction of Mount St. Helens with this massive multiplier, we really begin to truly understand the almost unfathomable proportions we're analyzing today. Section 2. The agricultural apocalypse. America's breadbasket buried.
20. Now that we understand the geological magnitude, we have to look at the immediate regional fallout. You see, the immediate danger isn't just the initial blast, it's the ash. A massive, dark red zone of destruction would rapidly spread all the way from Wyoming to the East Coast. And in some areas just west of the Mississippi, you wouldn't just be getting a light dusting. No, you'd be buried under up to 20 feet of heavy, dense volcanic ash. That is literally enough to swallow a two-story house whole.
Which brings us directly to the agricultural consequences. A staggering 95% of all U.S. soybean and corn farming would be totally ruined. Only a tiny 5% sliver would somehow survive. The data estimates that California's absolutely vital produce and the massive grain outputs of the Midwest would be entirely smothered. And this loss, it wouldn't just be a bad harvest for a few weeks. The assessment projects this complete devastation would last for several seasons, if not years.
Section 3. Global chilling effect. The stratospheric shield.
Now, as devastating as that ground-level ash is, the real-world ender consequences actually take place high above us in the sky. Let's move to and see how this builds. Let's walk through this chemical reaction systematically. Step 1. The eruption violently injects millions of tons of sulfur dioxide straight up into the stratosphere. Step 2. This gas undergoes a rapid conversion into sulfuric acid aerosols. Step 3 is where the serious climate impact hits. These newly formed aerosols act like a massive mirror, actively reflecting incoming sunlight away from the Earth. And finally, step 4. Because all that solar radiation is blocked, global temperatures just completely plummet. This severe chilling effect could actually last for up to 3 full years.
Section 4. The human cost. A planetary chain reaction.
So we've looked at the ground and we've looked at the sky. Now, zooming out to the macro level, we see that this is fundamentally a global issue. We are looking at a terrifying list of cascading failures. Those sulfuric aerosols was just discussed, they circulate the entire globe. And because of that massive shift in temperature, tropical monsoons completely crash. These consecutive failures of our global weather systems lead directly to our next point. International food supplies are destroyed. So the crucial point is that the international food web simply snaps, and global vegetation could literally take decades to fully recover. And the ultimate consequence of that multi-year agricultural failure is summarized in this stark warning directly from the scientific assessment. Mortality rate could reach hundreds of millions to billions of people primarily through mass famine. Hundreds of millions to billions. It is a staggering reality to process, right? The primary threat to human life globally wouldn't actually be the explosion itself, or even the suffocating ash, but the absolute collapse of the global food supply leading to mass starvation. Section 5. Are we safe? Monitoring the sleeping giant. Okay, I know those previous models paint an incredibly dark picture, but looking at the timeline of these events actually delivers some profound good news. First, the frequency, roughly 15,000 years. These events are exceedingly rare in geological time. Second, looking at the present day, we are not flying blind out here. There is 24/7 monitoring happening at geological stations right now. We're constantly listening to the giant. And third, now, what's really interesting about this slide is because of all that modern monitoring, scientists estimate we would likely have weeks or even years of expected advance warning time before a supereruption ever occurred. Which leaves us with this final, incredibly critical question to consider. If those monitoring stations actually picked up the warning signs tomorrow, how would humanity prepare for years without a single harvest? It's a provocative thought that really underscores the gravity of the threat we've explored today. The science shows us exactly what the planet is capable of. The real question is whether our global society is capable of surviving it.